Hello. Today I'll be showing you how to install Kratix on AKS, as well as how to register a work cluster of Kratix, and showing you the basics of how to use a promise. I'll be following the docs on the docs.kratix.io website throughout this process. I'll leave a link to this in the description. I'll also be using the quick start guide we have here in the Kratix examples for how to gain access to any of the credentials required to communicate with Azure. So, first things first, we need to set up our platform cluster. So in this case, I've already pre-created a Kubernetes cluster in Azure. So I already have my platform cluster pre-created. But if you don't have one, you can follow the AKS getting started docs to create one. So now that my cluster is created, I want to go ahead and log in to the CLI. So we can use the Azure CLI to get the credentials for the platform cluster. I should now be able to get all the pods in the platform cluster just to test that my access is working. Perfect. Now, throughout this demo, we're going to be referencing back to the platform cluster and the work cluster. So to make lives a little bit easier, we're going to set up an environment variable to reference what the name of the context is for this cluster. So we can see here the name of this is platform. So let's go ahead and export the platform environment variable to be equal to platform. Cool. So the first things first is that we need to install Set Manager. So let's go ahead and copy this and install it onto the platform cluster. So we're installing Set Manager first because Set Manager is a dependency of Kratix. The reason for that is that Kratix has some webhooks. These webhooks require certificates, and we use Set Manager to handle the provisioning of those certificates. Now that we've installed Set Manager, let's wait for the pods to be running. Cool, so we can now see that Set Manager has been successfully installed. So the next step is to install Kratix. So in this case, we're going to take the manifest for the latest version of Kratix from the Syntasso Kratix repository and install that into the cluster. Cool, now that Kratix is installed, let's wait for the pods in the Kratix platform system namespace to be running. Cool. So now we can see Kratix has successfully been installed. We can move on with the rest of the installation. So the first thing we want to do is set up a state store with Kratix. So a state store is letting Kratix know about a place where it can write documents to. So this place can either be a Git repository or a S3 compatible bucket. So in this case, because we're on Azure, we're going to use a Azure DevOps repository. If you don't already have one created, you can follow the documentation here to get one created, or you could use your own alternative Git provider as well, or a S3 compatible bucket. So in this case, I already have a Azure DevOps repo created, so I'm going to go ahead and use this repository. So what we need to do is create a Git state store and a secret as well to tell Kratix how to access this Git repository. So I was following the quick start documentation here on the Kratix example repository to pre-create this secret. There'll be a link to this in the description for you to follow along with. So I'm going to go ahead and install the state store. So what I have is a Git state store configuration. So in this case, I'm telling Kratix to write to my repository in Azure DevOps, and I'm telling it to use this Azure credential, which contains the credentials for communicating to this repository. I'm not going to show you this, but the guide on how to make this is in the repository. So let's go ahead and install this. So on the platform cluster, we can install the Git state store secret, as well as the Git state store. Cool, now we have our state store created. So the next thing to do is create a destination in Kratix. So destination is the thing that brings together a state store and to make it actually schedulable so documents can be written to a state store. So in this case, we're going to create a work cluster, and we're going to tell it that whenever Kratix tries to schedule things to this worker destination, it should result in files being written to that state store. So I have this already created locally, so I can show you my destination. So in this case, I'm creating a work cluster, giving it a label environment dev, just as an example. And in this case, I'm telling it to use that Git state store that we just created. So we can go ahead and install this destination. So what will happen now is Kratix will take this installation in and write down some canary resources just to check that it correctly has access to write to this Git repository. So we should be able to go over to our repository, refresh, and we can see now that Kratix has successfully started to write files to this Git repository. So we can see here it's created some canary resources that we will come back to later. So we've successfully installed Kratix, set up a state store, and configured a destination of Kratix. So the next step is to set up the work cluster. So again, like before, I have pre-created a work cluster in AKS. But if you don't have one, you can follow the Getting Started guide to create one. So again, we need to log into this new cluster. So using the Azure CLI, we can log in to the work cluster. And just like last time, we're going to set up some environment variables so we can switch between these two clusters very easily. So in this case, the context is just called worker. Let's go ahead and export this environment variable. Cool. So first things first is we want to install Flux onto this cluster. Flux is going to be the tool that's responsible for pulling down documents that get written to our Git state store and applying them onto the Kubernetes cluster. So in this case, I'm going to use the Flux CLI. If you don't have the Flux CLI and you're just using this cluster for testing, we also have a static manifest available in the static repository. But using the Flux CLI is the recommended way to do this. So I'm going to go ahead and run Flux install. And because I'm already targeting the work cluster with my keyconfig, it will install it into the work cluster. Cool. So now Flux is finished being installed. Let's check the pods to see if they're running. Cool. So we can now see if the Flux is successfully installed. So the next step is to configure Flux. So like I was saying before, Flux will be the tool responsible for pulling down the files from the Git repository. So we need to first of all teach Flux about the Git repository and then tell it to pull down the files from the Git repository. So in this case, we need to create a Git repository resource and some customization resources. So let's create our Git repository first. So in this case, I've already got the manifest ready for it locally. So let's go ahead and take a look at that. So in this case, very similar to what I was doing in Kratix, in this case I'm teaching Flux, where my Git repository is, as well as the credentials to use when to access it. So let's go ahead and install this. So the first things first is that we should install the secret, followed by the credentials. So we can apply the Git repository secret and the Git repository itself. So now that we've installed those, we can check the status in Flux to see if they're healthy. So let's get the Git repository resources. So here we can see that Flux has successfully managed to check out the repository, so we know we've configured it correctly. So the next step is to create the customizations. So I already have these locally here. So in this case, like I was saying, two different customizations, one looking at the dependencies directory, the other one looking at the resources directory. So we can go ahead and install this as well. And like before, we can watch these to see if they're healthy. So if we get the customization resources, we can see that the dependencies is healthy. And after a few cycles, we should also see that the resources will become healthy as well. Cool. So we can now have both the resources and dependencies being healthy. So, like I showed you earlier, Kratix creates some canary resources for these for the cluster. So in this case, the two things it creates is a namespace, so a Kratix work system namespace, and a config map inside that namespace. So this is just testing that Kratix is correctly wired up and that Flux is correctly wired up to receive these workloads. So it should be, if we go to the work cluster and we get the namespaces, that we should see our namespace. So here we can see the Kratix worker system namespace, and if we were to get config maps within that namespace, we should also see them. There we go. So we know we have successfully wired up Kratix to communicate to the work cluster. So that's it for installing Kratix. You now have successfully got a platform cluster with Kratix running, and a work cluster configured to receive documents from Kratix. So the next thing we're going to do is just install an example promise on Kratix and use it. So in this case, I'm going to be using a SQL promise that's available in our Kratix marketplace. So marketplace is a place where we have a bunch of available promises that you can use to test around and play with and modify as you please. So in this case, I'm going to use our SQL promise that is designed for Azure to provision SQL instances in Azure on demand as a service. So in this case, I already have the promise files for this locally, but you can copy it down from the repository here. So the first thing we have to do is create a secret. So this is giving the promise access to provision SQL instances in Azure using a service principal. Like before, a guide on how to create this is available in our quick start documentation here in the Kratix examples repository. And again, there'll be a link to this in the description. So I've already created this locally, so I'm going to go ahead and install the secret. Now that the secret has been created, we can go ahead and install the promise onto the platform cluster. So now that we've installed it, we can watch and wait for it to be available. Cool. So we can now see that the SQL promise is available. So we can go ahead and make a request to provision a SQL instance on Azure. So in this case, I've got an example request here where I'm asking for a small database. So let's go ahead and make this request. So this is going to kick off a pod to be created. And this pod is the workflow. This workflow is responsible for actually going and communicating with the Azure API to create our SQL instance. So we can see our pod is starting up. And what we should see is that while this pod is running, that we can see resources getting created in Azure. So let's go ahead and take a look. We can now see that the SQL instance is being provisioned. So in summary, uh, we just saw how to install Kratix on a platform cluster and how to configure it. We also showed how to register and configure a work cluster with Kratix, and then also demonstrated how to use the Azure SQL promise. So if you're interested in learning more, I would recommend going and checking out the docs. You can see a link to it here, as well as a QR code to scan. The docs have some other guides about how to get started with Kratix and other promises you can use. I'd also recommend taking a look at the Kratix marketplace. There's plenty of example promises you could use in here to play around with to just test Kratix out, as well as checking out the Kratix example repository to see some of the other quick start guides we have for some of the other cloud providers. Thanks for watching.